Thank you for joining me in the afternoon. I do realize I'm the only thing standing between your drinks right now. So that puts a bit of a burden on my shoulders. But I'll make sure that it's going to be entertaining and hopefully inspiring for all of you. 5 ways open source will slow you down. I guess you're all here to learn how to slow down, right? I see people. Yeah, exactly. The chairs do invite for slowing down and relaxing a bit. That's exactly the idea. Before we get started, I have a little confession to make. I'm a bit of a train nerd. The people that know me, yeah, I see 2 people from Dutch Railways. Thank you, much appreciated. I've actually been with the Dutch Railways, and a few of your colleagues, train drivers, were kind enough to provide me with the following detailed information about this particular type of train. It weighs a rough 193 tons in this combination. Actually, the picture is taken in my hometown, Apeldoorn. Any guess as to what speed it can reach? And people working at the railways are excluded. 140, that's right, 140 kilometers an hour. And by the way, it takes a little bit under 2 minutes to get there. If you give it full throttle, that is, 2 minutes to get there. My electric car can do that faster, but it doesn't weigh 193 tons. Another popular type of train in the Netherlands, this one's called, most people call it Sprinter. Technically, it's not a Sprinter, I know. Used for short-haul services, unlike the previous one, which is for long-haul services. This one can top also at 140 kilometers an hour, if I'm not mistaken, weighs a little less, 138 tons, and it gets at operating speed in a little under 1.5 minutes. And now you might be wondering, what has this to do with open source? This is about accelerating trains. Why can trains accelerate? Why can they operate at that speed? Because all trains have this as well. And if you're Dutch, you know this is the emergency brake. Any idea, have you ever been in a train where the emergency brake was pulled? I have. I see a few hands. How long does it take before the train gets to a standstill? More than 2 minutes. Every train, every passenger train in the Netherlands can come to a complete standstill in under 750 meters. I think that's impressive given their weight and their speed. I've been in a train that did that, and the train driver said, please apologize. And that was necessary for some people, because they were like, what's happening here? That was really intense. Accelerating. You can only accelerate if you know you have something that slows you down. And if you know what slows you down, and you have this emergency brake here in this case, then you can safely speed up. And it's a bit of this principle that I would like to follow through this talk. If we know what slows us down, we also know what will accelerate us, right? So that was the irrelevant part about me. The other irrelevant stuff is my name. You know I'm Maarten Mulders, I'm a Java champion, I'm an Oracle aide. I work at InfoSupport, which is a consultancy company, and which is maybe the most important for this talk. I work on the Apache Maven project. I've been committed for a couple of years. Recently joined the program management committee. So consulting and open source, what does that have to do with each other? That's the answer that hopefully you know at the end of the talk, plus a way how open source will be your accelerator rather than your emergency brake. Right? Before we dive into that, I need to talk about a little bit about software. Software. If I'm saying software today, what I mean with software is a set of instructions that we can store in the memory of a computer so that the computer can later execute those instructions. It's as simple as that. And the first real-world occurrence of software was actually on this little computer called the Manchester Baby. Well, babies are typically small in my experience. This one, as you can see, is not particularly small. It was built in 1948, just after World War II. The British had gained a lot of experience in code cracking, especially cracking the infamous German Enigma cipher engine. They did that at Bletchley Park, if I'm not mistaken. And they were like, okay, computers, we want to investigate that field further. And up until then, many computers were actually limited in their operations by what the hardware could do. So if you had hardware that could do addition, your machine was able to do addition. If your hardware could do subtraction, your machine could do addition and subtraction. This machine could do addition and subtraction, but not multiplication or division. But they built software to do that. Using the hardware they had for addition and multiplication, they implemented software for division and multiplication. We're really looking at the baby age of software here, right? I mean, addition and multiplication are not the most complex problems in our field anymore. Back then, they definitely were. So the machine was designed to actually prove that hardware could reliably run for many, many hours and produce a reliable result. So the computer, the Manchester Baby, was tasked to compute the highest proper divisor of 2 to the power of 18, which is roughly 250,000, using only addition and subtraction as hardware capabilities. The remainder of it, again, was software. Well, they wrote a program for that using, well, as I said, the hardware that they had. And the program would run for roughly 52 minutes. I heard this talk by this guy from Gradle about developer productivity and fast feedback times. Wow, 52 minutes to print "Hello World" in his example. That's insane. The program had, by the way, only 17 instructions, so that's a relatively small program, yet it took 52 minutes, ran 3.5 million operations. That boils down to roughly 1,100 per second. I think our smartphones today are a bit faster than that, right? But to eventually to calculate the correct answer, which is 130-something thousand, but that doesn't really matter. Software, the first occurrence where the machine was capable of doing something that its hardware could not. Fast forward a couple of decades, we see the first occurrence of software that really came to people like you and me, the Apple II. And the Apple II became a very popular personal computer. Why? Not because it was an Apple product and it was by definition hyped, but because it had VisiCalc. And if you don't know VisiCalc, like I don't, because I'm way too young for that, VisiCalc was like Excel, but less powerful. But it was marketed because of VisiCalc, because now you can create your home budgets and you can do energy price comparisons all by yourself using the modern power of the computer. We're talking spreadsheets here. See, the thing that all business software runs on either SharePoint or Excel, there must be a source of truth in this, because actually this is business software on, well, something that later became known as Excel. So, very popular machine because of that capability. But the thing is, with the broader distribution of software, it became also more easy to distribute software. First, there was only the computer and there was the magnetic drive. But then came floppies, then came disks, then came flash drives, bulletin board systems, the internet, FTP server, the Pirate Bay. We all know them, probably, or have at least heard of them. And it became easier and easier to have a copy of software package and give it to somebody else, which caused software vendors to start thinking about licensing. Under what conditions are you actually allowed to use the software that you have just bought? What can you do and what can you not do with the disk or the CD-ROM or whatever that you've bought? And one of the things that was quickly taken in basically all commercial licenses was you can't redistribute. Obviously, as that was the main way for the software vendors to make money. And if I am allowed to redistribute whatever the price I'm doing it at, they're not earning money. So actually, those distribution mechanisms made it necessary for vendors to think about licensing and actually limiting what you can do with the software that you've just bought. I think it is safe to say that nowadays, 2023, software is changing the planet, and not even our planet alone. We're even changing other planets. This is the Mars rover, and maybe if you're active on GitHub, you have this little badge on your GitHub profile. Anybody who has this badge, by the way? Nobody. Oh, I would have expected some people. It's a badge that you get if there's at least one commit of yours in an open source project that is used to build the software for this Mars rover. Then you get the badge, your code runs on Mars. How cool is that? I mean, sure, my code runs on my machine, and it runs in the cloud, and it runs maybe on somebody else's computer. Oh wait, the cloud is somebody else's computer, but never mind. But it runs on another planet. Wow, that is inspiring in a way, right? Okay, so now we know what software is. But what is open source software? Well, open source software is software where the license gives the copyright holder the rights to use, to study, to change and distribute the software and the source code to anybody for any purpose. Well, that's quite a big difference with what these commercial companies were doing, right? I mean, it's either you can get your copy, but you can't resell it, you can't distribute it, you can't inspect it, you can run it. Versus, well, whatever you see fit, just do whatever you like. There's even a do whatever the fuck you like license, if I'm not mistaken. I don't know the exact name, but it roughly goes like that. And it's literally like, whatever, we don't care, but don't blame us. That's usually the culprit. Other terms under which we know this is free software or Libre software. And I need to dive into that a little bit, because that can sometimes be a little bit confusing. So there's open source, there's free, there's Libre. What's the difference? What's the thing there? Well, it almost every time boils down to this. Is it free beer? Is it free speech? Free beer, talking about the drinks later on, we all know that. It's a drink, I'm getting the drink, I don't have to pay for that. That's what many people think open source software is about. It's free. I don't have to pay for it. I don't get an invoice saying you need to pay money. But open source software is often called Libre software because Libre has more of this meaning like free speech. We can talk about it, we can inspect it, we can change it. That's an open mindset, a mindset that invites each and everybody to participate in the process of creating that software, rather than the vendor saying, this is our secret, and you're not allowed to dive into that. And to see how open source history came to life, and the people that follow me on Twitter may have seen this picture, we have to go back way before the software era. This is a T-Ford. It was created back in the days that there weren't any computers, let alone software. And the T-Ford had an engine that was not developed by Ford Motor Company. It was developed by another car company. They had a new type of motor engine, a two-stroke engine, and Henry Ford was like, that's a brilliant idea. My cars need that too. But the other company had patented the issue, the idea, the design. And Ford said, well, it's such a brilliant idea, I'm gonna try to fight the patent. And he won that case. So then he was also allowed to build engines that do a two-stroke approach. And this effectively, this was one of the things that led to the creation of the American what's his name again? The the Automobile Manufacturers Association. Right, that's it, the Automotive Manufacturers Association. That's a group of companies in the United States that all produce automobiles, and they agreed that if they have a patent on a particular new idea or technology, they're not keeping it to themselves, they're sharing it with the other companies that joined the association. This is, in a way, the first open source, because we're basically saying, well, they are basically saying, we don't keep the ideas to ourselves, allowing only ourselves to make money out of it. We're sharing that with people so that they can also benefit from it, so that they can improve upon our initial ideas and make it even better. And in the end, it was, in a way, still limiting, because you had to be in America to join the association. So it was also protecting against foreign car manufacturers, of course. But there was a sense, a culture of collaboration under companies that until then would fight each other and compete. And they still compete, obviously, but here was a place for them to share ideas and to come to even better versions of that idea. So this has nothing to do with code, of course. This is a little bit closer to computers. It's a PDP-11, one of the first more or less mainstream computers, not for the general audience like you and me, but this was for many companies an affordable machine. It ran Unix, and it was the first time that the vendor of the machine, AT&T, said, well, you're not getting the source code of the operating system anymore. Until then, if you bought a computer, you would get the whole source code for the operating system, including all the programs that came on the computer. It would all be yours to inspect, to change, to alter, whatever you would like to do with it. And here, AT&T said, well, we'd rather keep that to ourselves. You can have the binaries, you can run it, but you can't change it anymore. And that was quite a big shift, but it followed upon the fact that, well, people were inspecting that code and trying to adapt it to run on other machines that were not sold by AT&T. So they had, again, a commercial reason not to make it too easy to change or to even study that program code. And that soon became kind of the de facto practice. If you would buy a machine, you would get the software to operate it, but you would not get your hands on the source code anymore, because other vendors were like, well, if they can get away with it, then so can we. And you would get a computer with binaries, and if you would be lucky, it would run, and it would work, and it would do whatever you would like it to do. And if you were unlucky, like this man, then one day your printer would stop. This man, by the way, is Richard Stallman, and the urban legend is that one day his printer stopped working. You know, nothing new in the field. I mean, printers still don't work. And back in these days, the 1980s, I believe, printers also didn't work. You'd say the industry catches up, but apparently it doesn't. His printer didn't work, and he figured out soon, by just opening the machine and inspecting all the machineries in there, that it wasn't a hardware problem this time. It was a software problem. But yeah, he didn't have the software, because the vendor said, yeah, you can have our printer, you can have the driver for the printer, but you don't get the source code for that driver. So he figured out, by reasoning, by inspecting the electronics, I should be able to fix this. I don't have to send the printer back. I don't have to repair it. It's only software, but I don't have the software. And out of that frustration eventually grew what we now know as the GNU project. A project that strives to build completely free, as in Libre, open for inspection, change and adoption, software to run on your machine and to run on your printer as well. Another very influential person in this field, and I figure that many of you have already thought, where is this person coming to the field? Linus Torvalds. Back in the 90s, he wrote his first operating system. I believe he introduced it as a Minix clone, and it would probably only run on AT hard drives, because that's the only thing I have lying around here. Maybe you have seen the initial mailing list message that he shared, like, okay, I've created a little something. Well, that little something is the Linux kernel that operates more than half of the hardware nowadays in the world. I think it's safe to say that. Because he invited people to actually go and contribute, to study what he did, to enhance it, to provide new features. And well, he didn't have any other hard drive than an AT hard drive, but somebody else had a different hard drive and was able to write a driver for that hard drive. So hey, look, the kernel just got a tiny bit bigger, and so on, so on, so forth. Nowadays, it runs many clouds. It runs your smartphones. It runs, well, maybe it runs even on this clicker. I don't know, but I wouldn't be surprised if even this was running. Now, maybe Linux is a bit too heavy for it, but you get the idea. It runs on so many devices nowadays, from very powerful supercomputers to Raspberry Pis that live in your attic and wait for your next hobby project to finally be done. Or does anybody have hobby projects that actually reach production? Because I don't, but maybe some of you do. So these two people were really influential into making open source more popular and making it more accessible to many, many more people. And in the case of Linux, it really also helped that that we saw Linux distributions showing up. CentOS, Gentoo, Ubuntu, Debian. Not in any chronological order, of course, but the fact that groups of people started to combine packages, software packages, into a ready distribution that you could download on your machine, install, and just run. That made open source really interesting. That was really a catalysator for the general audience to be able to use open source software. So, with all of that definitions and that little piece of history book copy-paste out of the way, I want to share a story with you. And I mentioned in my introduction that I'm a consultant, and this story is about my experience as a consultant. And I have to make a disclaimer up front: any resemblance to real persons or other real-life entity is, of course, purely coincidental. You never know. Somebody walks up and says, well, that was, no, don't worry. So what do we have here? We have here one of the teams that I'm working with at a project that I recently ran. And you can see that the team is, well, I would say that they're not 100% happy, right? They look a bit worried. Apparently there's something going on. There's a bit of nasty stuff, and that they don't know how to solve, and discussions. And the thing is, this team is working on a project that started off with all kinds of great ideas. Great ideas about new businesses to explore and how software would actually help them reach that market, break it open, earn profits. Great ideas, designs, but one thing was lacking a little bit, as usually, by the way, which is budget. Being part of a larger company and still not having the proper budget to build this, there was an easy way out. We have open source software, which is free, and we can build amazing things with that. So let's just use as much free software as we can, because that will drop our cost, right? So then we can have enough on this low budget. It will still be enough to reach what we want to reach. Well, excellent. They set forth. They started building, until one day things weren't looking so bright anymore, because it goes well for a little bit of time, and then after some time, some shitty thing happens. And in their case, it was a security report. Somebody inspected what they were building, and they said, well, there's a few problems in your project. You're not doing the things right. In fact, we found a few security vulnerabilities, and they mentioned things like something spring, something log for whatever, and well, yeah. Well, that brought them to the picture that we saw first, like worried faces, and what are we going to do next? Because well, we don't know. So, well, what did they do? Well, the security researchers said, well, just reach out to your vendors and see if they can assist you. Seems like an obvious reaction, right? If you find security problems in your projects, you reach out to the vendors whose products that you use, and you ask them if they can help you. So, all right, they started writing a few emails to the vendors of the software products that we're using. And let me share some of the examples with you. This one, for example. And I've blurred out so that you cannot see the relevant details, I mean the irrelevant details, but the relevant details are still there. This is an email that they sent to somebody's private email address. Yeah, I found your contact address on the Maven team website. We are a licensed user of Maven. We currently have version 3.6.3. Our security system flagged as vulnerable to log4j, CVE, whatever. December 12, 2021. And the email message continued. We're looking for an official response if versions 3.6.3 and or 3.A4 are vulnerable to log4j. Okay, well, you'd say that's a relatively polite message, right? I mean, could you please help us out? And by the way, if you're not the right person to contact, then please could you redirect us? Yeah, this was indeed the polite approach, because we also had, I mean, they weren't that coordinated, a different message, which literally said, it's critical for all of our vendors to determine if their software is impacted so that remediation steps can be taken. We need your company to respond to the following questions immediately. Bam, whoa, back down. Immediately? We need you to respond immediately? Wow, that's, I wouldn't say that's polite anymore. And then follows quite a big list of questions. And I've even seen more recently, from my own experience, a message like this, with an attached spreadsheet in Apple numbers format. And, well, I usually have a MacBook. I don't have one today. But, I mean, that's expensive software on expensive hardware. And you expect random people out on the internet to be able to read that. I think that's pretty privileged in a way, right? I mean, come on, not everybody has a MacBook at their disposal. Not everybody has numbers installed on it. At least use an open format for, if you have the guts to ask such questions, then at least use an open format. Anyway, this example, this very example, brings me to the 5 ways that open source could slow us down. Because number first, for me, by far, is treating the community as a vendor. Approaching them like they are your vendors, approaching them like you have any right to demand a response or to demand a fix or to demand whatever. That is not a way to accelerate, that's a way to slow down. Because you know what happens in such a community, and as I said, I am in the Apache Maven community, and I can tell you what happens on the Slack there. Oh, those guys are not getting an answer for sure. And that's the polite version. I see some people that maybe have seen the same conversation on the Slack. It was like, there was a bit of cursing, like they can, whatever. So that's the first thing that you definitely should not do. Treat an open source community as if they are selling you something and that entitles you to ask, to demand actually their immediate response. Remember that if you're using open source software, it is, at the start of the day, apart from free speech, it's also free beer. You didn't pay anything. So what gives you the right to do that? It will work against you because they will not be willing to help you. Second way in which open source can slow you down and will slow you down. Find a useful library on the internet and be like, yeah, that looks useful. I'll just copy paste that code into my own code base and be done for the day. Sure, that's a quick approach, but it's not productive. It will work against you. Because if that code gets improved over time, log4shell gets resolved, or there's a bug fix, you won't get that. You won't get that improvement. Because you just copy-pasted the code, including all the bugs. You got the bugs for free, that's the good news. The bad news is you won't get the bug fix for free either. So copying and pasting is definitely not the way to go. And if you find an issue in an open source library, what do? I just spoke in the hallway track, which, as we all know, does not get recorded, to somebody who said, well, we have it as an official company policy that if you find a bug in some open source software that you use, you shall report that, and you cannot close a pull request that introduces a workaround unless you refer to the public issue tracker where you reported the issue. And I think that's a very good first step, because it makes sure that you at least document the issue that you run against, and maybe you have tight delivery. Sure, we all have that every now and then. But at least you document, we found this issue, or we believe it's an issue. We reported it over there, and these couple of lines of code are a workaround against that bug. So if that issue gets resolved, you can at least track back into your own code base which workaround you need to remove if that bug fix gets released and comes into your project. Fourth, get started with an open source project, integrate it in your code base, be happy that it works, and then call it a day. Job done, ticket closed, deployed to production. This is not going to help you. This is going to slow you down. Why? Because it doesn't allow you to improve. It doesn't allow you to check back if you did it the right way, if there may be a better way. It will work, and if you're lucky, you know why it works. And if you're unlucky, you don't even know why it works, because you just followed the documentation and you don't actually understand. And that brings me to the fifth and final one, which is following the tutorials. Really, don't do that. Okay, well, do it, but don't stop at following the tutorial. You know, every open source project has like this getting started, which will get you to the hello world stage in less than 5 minutes, right? Just copy paste a few snippets of code, compile it, run it, see, hello world, look, I'm a brilliant developer. But that is not going to help you in the long run, because you don't understand yet how the project works. You don't understand its powers. You don't understand its limitations. Studying, really understanding that library that you've just pulled into your project, that is going to help you. Because then you know what you can do with it, what you maybe should not do with it. So I've already given a few spoilers, because obviously this talk is not about me encouraging you to slow down. That would be a bit of a strange goal for such a talk, would it? I mean, yeah, take it easy. We don't need to accelerate. Well, sometimes we do. And I believe that open source can be an accelerator. So if we learned how open source will slow us down, then now we can really dive into how open source will help us accelerate and reach that whopping 140 kilometers an hour, even if we are close to 200 tons heavy. I'm not there yet. So, first, rather than treating your community as a vendor, treat them as collaboration partners. Work with them. Don't expect them to do your work, but work together with them to help improve their product, because their product is part of your product. If their product grows, improves, nurtures, then so will your product. So collaborate, reach out, see how you can help. See how you can find issues, find solutions for issues that you run into, rather than saying, here's the Excel list in a proprietary format with 15 questions that you need to answer. Maybe if those questions are relevant to other parties as well, make it public documentation. Why is this product not affected by log4shell? Well, because blah, 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 blah reasons. I think many projects will be happy to have such documentation somewhere in their public documentation, so that every time anybody sends that kind of email message to a user's mailing list, apart from ranting about it on private communication channels, you can simply redirect them and say something like, let me Google that for you, because it's on our public documentation. That's collaboration. That's improving the documentation of that product. It doesn't have to cost much. It doesn't require you to be the most excellent coder in the world, a 10x developer or something like that. It just requires you to do a little bit of work to nurture that product. And that reminds me of a tweet that I saw recently by Gert-Jan Wielinga, who is also very passionate about this topic. He said, well, if any big corporation with deep pockets approaches an open source community and says, we demand that you do X, Y, or Z, or that you answer these questions within 48 hours, and I'm not joking, I've seen those messages, within 48 hours, then the right question to ask is, what is the relationship that your company has built with us as a community that enables you to make the demands that you're now making of us? And if the answer is we don't have such a relationship, then I think the answer is also obvious to the initial email. But if the relationship is, well, we've contributed a lot of, excuse me, a lot of fixes to your product, and we've been working to implement this new feature that was in high demand, and now we're asking, can you please help us because we are on a stretch here, then I think your question will be treated differently. I'm not saying it's a guarantee that you will get an answer, but at least you will not be considered like the biggest idiot on earth that asks these kind of questions. The second thing that I highly advise you to do is using dependency management instead of just copy-pasting that code. So by using dependency management, and by the way, I'm not saying it should be Maven, but it should. But you can even use Gradle or Ivy or whatever. I don't really care. But use a use a standard. Okay, you can even use npm, but only for today. Use such a tool. Check in the dependencies that you use. Make sure that you know exactly which version that you have, so that your build does not contain any surprises. Because if you have that, it becomes also a lot easier to answer those questions that we just saw before. And if a project releases a new version, oops. Oh wait, that's not this one yet. I'm sorry, that one will come later. Rather than doing the workaround approach that I said earlier, like, okay, I'll just change my code a little bit and the bug is gone. The really cool thing to do, and I think many projects will be thankful if you actually do this, is reach out and report that issue. Almost all open source projects have an issue tracker. They allow you to report an issue, to just say, hey, I'm trying this, I would have expected this outcome because that piece of documentation says so, but I'm seeing different behaviors here. What am I doing wrong? Or is this maybe a bug? And it would be even better, and that will really give you a lot of karma points, if you include a minimum reproduction for your problem. Minimum reproduction being a very small piece of code or a very small sample project that illustrates your setup, the problem you run into, and how the community can actually reproduce, hence the name, the issue you're facing. I cannot count the times that I've seen issues in issue trackers like, I'm trying XYZ and it doesn't work. Okay, what does your code look like? Sorry, cannot share, it's private code. Okay, then how do you expect me to actually troubleshoot your code? If you can't even show me the code, it can only tell me that you're invoking one particular method and it doesn't do what you want. What did you do before? What did you do afterwards? I can't see it. I can't help you out. Give me a very small project that illustrates the crash or the faulty outcome of your calculation or whatever, and I'll be able to investigate and see if your expectation is right, and if your expectation is right, why the code does not give you the outcome that you have expected. So, contributing a fix is of course brilliant, but you don't always have the time for that, and that's perfectly fine. But at least file the issue and include a complete reproduction, a minimum but complete reproduction that helps the community reproduce the problem you're facing so that they can investigate what goes wrong. Next thing that I highly advise you to do after starting to integrate an open source project into your product is to periodically revisit. how are we using this particular library? Is it still in line with the documentation that they have themselves? Is it still in line with how others do it? There may be blog posts around that particular technology. How are they solving my type of issue with this particular library? Learn from that. Inspect if what you're doing is an optimal way or not. And sometimes the project will have documentation on this themselves. Sometimes maybe they will not, but then still, don't take for granted because it always has worked, it will still work. But come back every now and then, check out, are we still doing the right thing? Are we, especially with bigger upgrades, like Spring going to version 6, are we still on the right path? Or is it just like, well, my code still compiles, so it probably still runs. And the tests don't crash, so it probably still runs. Maybe they found a better way to do what you have been doing in the past, and you can learn from that. And while you're at it, and while we're talking dependencies and new versions of dependencies, please, please, please automate the heck out of that. Don't try to do that by hand every time. Don't try to run test cases again. Don't even try to do the dependency updates by hand. Use a tool. There's plenty of options. If you're in the GitHub space, there's Dependabot. If you're running Azure DevOps or something like that, you can use Renovate, and there's probably a few competitors whose names I forgot. I apologize up front. But this is a solved problem. Don't try to do this yourself, but leverage the tools that are there that help you automate this. These tools can create the pull request. The pull request will get built, will run your unit test, your integration test, your code quality checks, everything. And if all looks green, some of them may even be able to automatically merge your pull request. I don't know if you can go that far in your organization. It depends on your context. Maybe you cannot, maybe you still need the manual sign-off. That's perfectly fine. But all the work that does not require human interaction, please, please automate that. And then finally, rather than only following the getting started and being happy that Hello World works according to the documentation, by the way, if the Hello World didn't work, what crappy documentation did they have? But aside, really take your time to investigate the product, the framework that you're using. Learn the concepts, understand how the technology works, and how the developers intended it to be used. Because that will give you powerful insights into, hey, but the product can also do this, or I can also use it to solve that particular problem. Making you way more productive than only doing the Hello World, seeing that it works, and moving on to the next problem. Maybe your next 5 problems can be solved with the same library that you've just started to use, but you just don't know yet until you start reading that documentation and seeing what other capabilities it has. So yes, actually read that fine manual. I know many developers are like, yeah, documentation, that's so boring, I don't want to read it, but it really pays off to do that. You'd be surprised sometimes by what a library that you already have on your project can do in addition to what you are using it for right now. So it's about time to wrap up. It's about time to head to the drinks, but not before I will leave you again with a picture of trains, because as I said, I just love trains. We have seen how open source can slow us down in dramatic ways, but we've also seen how open source can accelerate our project, can accelerate our work, and make sure that we are getting more and more productive. And to just revisit that quickly, collaborate with the community around that project that you're using. Use proper dependency management tools. Contribute back into that project by reporting issues and submitting patches. Review how you use the product and keep up to date with new versions of it. And finally, make sure that you really understand the products that you're using. If you think that is too long to remember, then please take away this one. Don't ask what open source can do for you, but ask what you can do for an open source community. And with that, I would like to wrap up your JFlow experience for today. Thank you very much for joining, and have a wonderful travel back home. Thank you.